I'll probably do that for you. Like if you say you're writing and you need more space, then this will move it down. Hi. Good. Okay, thanks. She's probably like, who are you talking to? Someone in my ear. She's like, okay.
All right, Madeline, go ahead and count to 10, nice and loud.
1, 2, 3, 4, 5, 6, 7, 8, 9.
That sounds good. So what you want to do is remember, every time that you're speaking to one of us, speak loudly, because they can always turn you down, but it's hard to turn you up.
Okay.
All right? When you are on the program, you always want to be very close to this countertop.
Okay.
All right? Because most of the time, we're going to be looking at that camera. Standing in back of me, because if I'm looking like this, they want to make sure they can see you, all right? Okay. Draco, they need you to count.
Okay.
However you'd like, they just need to.
Okay, sounds good.
Check your level.
1, 2, 3, 4, 5, 6.
This from a sitting position, you try to go like this, and then
Yeah.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy, and you can contact us at 636-4357, 1-866-636-6284. Email dothemath@kern.org or watch us online at dothemathonline.net, and look for us on social media as well, Facebook, Instagram, Twitter, YouTube.
All right, well, we do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. We have a very special guest in studio, that young lady we will meet later on, and she'll be doing a lot of math with fractions and mixed numbers this afternoon. We'll be going out to one of our local businesses, and we do have some students waiting to do problems on the phone. So we have a full day ahead, but before we do any of that, let's first take a look at today's Math in the News. All right, well, today's Math in the News has to do with this office, the Kern County Superintendent of Schools office. In studio with us right now, we have Traco. How are you?
Hi, Mike. Good to be back.
Nice to see you again. It's been a little while.
It has been.
All right, now you are with the Kern County Superintendent of Schools office.
Yes, I am.
And what is your position with the office?
So, Mike, I am the HR Director for Staff Development here at KCSOS.
So a lot of students, and even the one in the studio, maybe. So what does that mean? What do you do?
So in summary, I help leaders develop, I help them with professional development, so that means usually getting better with soft skills, learning how to communicate better, how to build relationships, how to be better managers and supervisors.
Okay.
I also connect staff with curriculum and programs to help them develop technical skills and also soft skills. So technical skills may be like computer skills or in learning how to work with Excel better, or PowerPoint or some other program.
So is there a certain amount of time you need to meet with people, or is it like, all right, I've met with you, you've kind of got it, and off you go now?
So a lot of the learning does happen via online platforms, and so it's self-study.
Okay.
Learning and growing via online platforms, but often we do in-class learning as well. And so we'll provide sessions and workshops for staff and leaders.
And it doesn't matter if they're a new employee or have been here for a while.
It does not matter. We want everyone to be part of the learning and growing that KCSOS has to offer.
Now, what kind of math do you do? Because obviously we're on Do the Math, and you may not do a lot of, let's say, formulas and things like that when a lot of people think about mathematics. But what kinds of math do you do? And remember that math also involves kind of problem solving, troubleshooting, things like that.
I would say that most of the math that I do on a regular basis is problem solving. Sometimes I may use a little bit of statistics, but most of the time it's using graphs and charts. I present a lot of information, a lot of material. Often pictures, graphs, spreadsheets, they can help tell a story that words don't do justice to.
And I know there are a lot of students and adults as well that they're visual learners.
Yes, they
right?
are.
They need to see something in order to grasp it a little bit better.
That's correct.
And you didn't just automatically know how to do this, right? You had to learn these skills.
Yes, I did.
And some people go, well, I'm more auditory. I need to hear it. I can't just read it or look at it. I need somebody to explain it to me.
Correct.
So have you found there are a lot of different ways and the visuals work best for you?
So over the years, I've developed Microsoft Excel skills. So I've tried to increase those over the years so I can get better with tables and graphs using a spreadsheet.
Okay.
I've also tried to improve my skills with PowerPoint. So there are a lot of things that you can do. You can program a lot of these platforms or delivery methods, but I use them generally speaking just for graphs, tables, and charts and so forth. Also Visio, Microsoft Visio is something that I've recently learned how to do, and it's pretty cool. So you can map out a whole process, talk about how one process moves from each stage to the next, and it's a nice visual presentation of something that is hard to explain in words.
Okay. Now, I ask this a lot of times of the students, whatever grade they're in, and if they especially are moving from one school to another school. What is the best thing you like about working with the County Superintendent of Schools office?
Wow, that's a tough question. The people are fantastic. I love working for Dr. Barlow and my boss, Tony Smith. They are amazing. They give me a lot of autonomy, so I get to dream and build things that I love to build. But also, just working in education is, I think, one of the best things that you can do as a professional. And so in my role, getting to help people fulfill some of those dreams of learning and growing is just amazing. I really love that I get to do that on a daily basis and ultimately help all of the students in the different districts that we serve.
Well, you know what? We certainly do appreciate you taking out some time, because I know this is kind of in the middle of your workday right now.
It's all right. Love
and
being here.
as long as you said your boss was Tony,
Yes.
as long as Tony's cool with this, you come upstairs for a little while and
Yes, sir.
do a little bit of this with us. So Traco, thank you very much for coming in.
Thank you so much.
And you know what? We do have phone tutors available until 5:30. And right now, what we're going to do actually is bring up the young lady this afternoon. Come on up, Madeline. And how are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Panama.
Come on, right up here. There you go.
I go to Panama Elementary, and I'm in 4th grade.
So Panama, you are a yellow jacket, correct?
Yes,
Have you been there for a long time?
I've been there since kindergarten.
Since kindergarten. So you doing all right with the place?
Yes,
Yeah? All right. Do you like going to school a little bit longer during the day now?
yes,
You like that?
yeah,
Okay. So it sounds like you like everything about school.
yeah.
If you could change one thing about school, what would that be?
I don't know. I like it.
You like it the way it is?
Yeah.
Okay. Is there one area that you like to study more?
I like language arts.
Okay. Is there a book that you guys are reading? Do you guys read novels?
Yeah, we do classroom books. Yeah, we're doing Holes right now.
Okay. And you're enjoying that? You like that?
Yes.
What is that about?
It's about a boy who is sent to a camp for boys who have committed crimes.
Okay.
And then he gets out in the end.
All right. Well, that's pretty good then, isn't
Yeah.
it? All right. You ready to do some math?
Yes.
All right. Head on over to the board.
Okay.
So this is some of the homework that you're working on, and we'll just go ahead and read it, and you guys can write down any information you need to. And then Madeline, as you're working through it, explain to us how you're doing it.
Okay.
All right, so here we go. Isla walked 3/4 of a mile each way to and from school on Wednesday. So this person walks 3/4 of a mile to school and 3/4 of a mile back home. How many miles did Isla walk that day?
Okay, so, whoops. So she walked 3/4 of a mile to school and then 3/4 of a mile back from school,
So
right?
B plus, and then 3/4. So
Can I ask you where this one came from? 1/3?
I don't know where that came from. I think I heard that.
Just heard it wrong.
3/4
Okay.
to school and back. So we're just gonna erase that. And then 3/4 plus 3/4. So the denominators are the same. So we can just keep that the same because you never change the denominator if it's the same. Then regular simple math problems. 3 plus 3 is 6. And then you can make that into a mixed number because it's an improper fraction. And 4/4 is 1 plus 2/4 which would be 1 2/4 of a mile.
Well, nicely done, especially with the vocabulary. Now, if you have 1 2/4, is there a way to simplify 2/4?
Yes, there is.
I was going to ask her that, but I wasn't sure about in
can
4th grade.
I can do the math up here. So you could divide the 2 and 4 both by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So it's 1/2. And this could work to 1 and 1/2.
Okay, nice job, Miles, right?
Yeah. Let's put that down there.
There you go. Nice job
Nice.
putting that unit on there. Well done. 636-4357 is the phone number. We do have phone tutors available until 5:30. Nice work right there by Madeline. Thanks again to Traco for coming in. And right now we have our first opportunity to head out and about and see where Scott is today.
Hey, we're here live at Robert Healy Construction here in Bakersfield. We're going to do a little math in the real world. We always want to know where that math is happening, not just in the classroom and not just on your homework, but of course in some businesses around Bakersfield. So we're going to talk today with Robert Hopkins, who's the Vice President. Robert, thanks for your time today.
Thanks, Scott. Nice to meet you.
Appreciate you being here. Okay, let's just start at the beginning. Tell us a little bit about the company and what do you all do?
Sure. It's Robert Healy Construction. We're an industrial contractor focused in the oil and gas business.
Okay.
We were founded in 1977 by Robert Healy, who actually started out as a welder in the Paso Robles or San Bernardino oil field. And he built the company up over the last 40 some odd years. And now we've got about 400 employees and work in 2 different states.
Yeah, so there's a classic Bakersfield, Kern County success story, right? Right from the oil fields and now has his own company. So how long have you been with the company?
I've been with Robert Healy about 4 years, and I've been in the oil business about 11 years.
Wow, okay. And before that?
I was actually in high-tech software sales.
Hey, a little bit of math involved in that too, right?
A little bit, yeah.
Yeah, there you go. And so when you got to this company, what did you do? What was your role then when you first started?
When I originally came over here, I was in charge of the estimating, project controls, quality assurance, and IT.
Okay, and that's a lot of stuff that maybe folks don't think about in the oil industry, right? There's a lot of background stuff, not just those pumps going up and down, and not just the guys getting all the oil all over their coveralls, but there's a lot of stuff going on. So in your role now, if you're not out in the field, you don't have your coveralls on today, what kind of things do you do on a day-to-day basis that help those guys be able to do what they need to do?
So it kind of depends on the group. Like I say, I got multiple groups underneath me. I deal a lot in the financial side of the business now. Okay. So I deal a lot with the numbers.
The numbers, yeah.
The profit and loss and things like that.
Right.
My estimating group, they deal with when opportunities come up, they have to price them. We have to figure out what it's going to cost to do the work, what we're going to charge our customer, how we're going to do the work. My product controls group, they're kind of the middleman of once we get the job, their job is to track the cost, track the productivity. So they're looking at, how much did we do? How much do we have left to do? What did it cost us to do it? What's it going to cost us to do it in the future? So everybody's got a little bit of math in that equation.
Yeah, no doubt. There you go. I like how you said that too. There's always some math going on all the way down the line. So you say you have a business here in Bakersfield, right? You got some businesses, places, and people that work for you here in California. But what kinds of projects are they doing in the oil fields? Do you install pump jacks, or are there other things that you do?
So we primarily do pipeline construction, flow lines, and facility construction. So we'll build pump stations, treatment facilities, a little bit of everything. We also run some waste facilities and recycling facilities. Pretty much anything from the wellhead to the sales pipeline we'll handle. Anything downhole is really a different group.
Gotcha. Okay, and so for someone kind of ignorant about the oil industry like myself, explain to me a little bit about this, right? Sometimes I think that those pump jacks are pumping oil out of the ground and we stick it right in the car, but there's a whole lot more, right? There's more that comes out of the ground and more that has to happen. So you say once it comes out of the ground from the pump jack, right? Mm-hmm. And then you're going to separate it out. Tell us a little bit about that process, what happens there.
Sure. So when the oil comes out of the ground, it's 80 or 90% water and 10 to 15 to 20 and oil in California.
Right.
So it comes out and then it goes to a separation facility, and that's kind of a whole fun another discussion about how they separate oil and water and gas.
Yeah.
But they separate that, and the oil goes one way, the water goes a different direction, and the gas goes a different direction. And then they measure it so they know what the percentages are, because they want to know what each well's producing.
Right.
And then from there, we'll talk about where the oil goes in a little bit later in kind of our discussion.
Yeah.
The water goes to a water treatment facility where they treat it, and most times re-inject it back into the ground. And the gas goes off, and they turn around and sell the gas as natural gas.
Right, right. So all kinds of things mixed in that are coming out of the ground, and we got to get them to the right place. Look at that, I'm learning stuff already. So, just so you know, when you see a pump jack out there in the oil field, it's not just oil coming up. We got some water, we got some gas, and we're going to learn a little bit about how, once things are separated, how to get them from place to place. But right now, I know there's some more math to do back in the studio, so we'll get there for a little bit. We'll be back in a bit.
All right, thanks for that, Scott. Always a little bit more math to do. We'd like to thank Madeline for coming in this afternoon. We'll get Madeline back to work in a few moments. But right now, we're going to go to the phones. And Caitlin, how are you this afternoon?
Good, how are you?
I'm wonderful myself. I do believe you have a word problem for us, right?
Yes.
All right, as soon as you're ready, let's hear it.
Flashing Lisa is a witch on a mission. As the ghost sheriff, she's responsible for stopping those ghosts who scare people a bit too much, thereby breaking Halloween bylaws. On this Halloween, she's had to fly all over the world. Her flight times from ghost to ghost have been as follows: 17 minutes, 20 minutes, 23 minutes, 19 minutes, 18 minutes, 5 minutes, 12 minutes, and 22 minutes. What has been Lisa's average flight time between ghost captures?
Okay, so your question is to find the average, right?
Yes.
Okay, so what do you remember about finding the average? What's your first step?
You add up all the numbers.
Okay, so we're going to add all these numbers. So let me just make sure I have the numbers. 17, 20, 23, 19, 18, 5, 12, and 22.
Yes.
Yeah? Have you added them yet by any chance?
Yes.
You have? What'd you get?
136 minutes.
All right, so let me double check. So that's
136?
10, 19. Did you add it for me?
Well, we're going to have Madeline do it right now.
Oh, okay. Madeline's going to
I've got a
calculate it for
professional
me.
with a calculator
Yeah.
here. So Madeline's going to check those. She's going to add them up right now and see if she gets 136
I'm
just
going to
like
write it
Caitlin
down
did.
just so I don't forget what you said.
136.
136.
Verified 136.
Okay, so they totaled 136, and then we need to find the average. So what's the next step for finding an average?
We divide by how many numbers we have, which is 8 numbers.
That would be
Okay,
8.
so 1, 2, 3,
So
4, 5, 6,
136.
7, 8. So we need to divide by 8.
Divided by...
Yes.
And then, so I could do this, right? 8. Watch me mess up. Okay, 13 minus 8, 5, 7. Okay, so I got 17. What'd you get?
17 minutes.
17 minutes.
That's 17 minutes.
I
An
love
even
how you
better answer
corrected
right there.
my forgetfulness of the label.
Now let's verify. Is that what you?
Yes, that's 17.
17 with the calculator
All right,
also. All right, nicely done, Caitlin. Congratulations on that. For phoning in this afternoon, you've got yourself a ticket to any movie of your liking, courtesy of our friends at Maya Cinema. So congratulations on that. We do have phone tutors available until 5:30 this afternoon. We have Madeline in the studio. She's been working right now, verifying everything that we've been doing. Now it's time for you to get back to work. You ready?
Yes.
All right, back over to the board, young lady.
Okay.
Let's take a look at the next problem you have on your homework. Zach spent 2/3 of an hour reading on Friday and 1 1/3 hours reading on Saturday. So we have 2/3 of an hour on Friday, 1 1/3 hours on Saturday.
Okay.
How much more time did he read on Saturday than he did on Friday?
So, since this is a fraction, but this is a mixed number,
Well, hold on a second now.
Yep, okay,
Before
so
you get started.
I was going to ask her. I was just
Okay,
kind of
so
waiting
go
for
ahead
her to
and-
finish the sentence. Okay.
Okay.
So let's put it in the right order, though. So we want to know how much more time he spent on
So-
Saturday, right? So which one should we start with in our subtraction?
1 1/3.
Because that's Saturday's amount, right?
Yeah. But 2/3 is a fraction, and it's not an improper one. So we should make this into a fraction first. So 3/3 plus 1/3.
And your 3/3 is because of the 1, right?
Yeah,
Okay.
I'm just writing
Just in
it
case
down.
anybody's wondering
Yeah.
where that came from.
And then that would be 4/3.
Move that out of your way.
Yeah.
There we go. That's good. You don't have to erase it all.
Okay, so now we have a new equation, 4/3 minus 2/3, which would be equal to 4 minus 2 equals 2, and 3, and since 3 is the denominator, it stays the same, so 2/3.
What's our label? Do you remember?
No.
It was hours, correct?
Yeah.
Correct.
Yeah.
Of
2/3 hours more, I guess?
an hour
Yeah, there you go.
more.
And you knew to subtract because they asked you how much more it was?
Yeah.
Okay, nice job.
Well, you are on a roll, so let's go ahead and take on the next one right
All
now
right,
while we've
let's
got a
go.
quick moment.
'Kay.
All right, here we go.
She's like, but I didn't write it down yet.
Mrs. Cashmore bought a large melon. She cut a piece that weighed 1 1/8 pounds and gave it to her neighbor. The remaining piece of melon weighed 6/8 of a pound. How much did the whole thing weigh?
Okay, so again we have a mixed number and a regular fraction.
And
So,
how'd you know to add? Let's just, in case someone's wondering how you knew that.
Because it said how much did the whole melon weigh. So that
that's
would be
The neighbor's
adding.
part, and that's their part,
And then together.
makes the whole melon. Okay,
Yeah.
good.
Okay, so again we have a regular fraction and then a mixed number, so we should convert this again. 8 and 8/8, which is this,
Right.
plus the 1/8 right here, would be equal to 9/8. So now we have a new equation again. So 9/8 plus 6/8
Just stop for just a little bit for you.
would be 15/8 because 9 plus 6 is 15,
Okay.
and 8, and the denominator's 8, so it stays the same.
Okay. So do you need to simplify it when it's an improper fraction?
Yeah, we should probably simplify it, and well, you can't exactly simplify this, but you can turn it into a mixed number because there's nothing that can go into 15 and 8.
Right.
And I have to pause for a moment because that is excellent use of the vocabulary because you're not simplifying, you're rewriting it. Right, so you're putting it in a different form because a lot of people might think, well, you're simplifying. Well, you're not simplifying it.
You're
just rewriting it.
Yes.
All right, so continue on that.
So 8/8 is 1 whole, just to put it down there.
Okay.
And then plus a blank fraction would equal to 15.
Here, let me move it
eighths.
a little bit again for you. Sorry. As you're
It's
writing.
all right. It's all right.
Just trying to get you not to have to write on the little.
Yeah. Okay, 15/8. So first we ask ourselves, okay, well the denominators are 8 in both, so we already know that. And what plus 8 will get us 15, which is simple addition. It's 7. So it would be 7/8 equals. So that would be equal to 1 7/8. 1 7/8.
And then this was pounds for the watermelon, right?
Yes.
So pounds.
Pound.
So Madeline, looking at the original problem that you had written up there, 1 1/8 plus 6/8. If you don't even worry about the whole number, just take 1/8 and 6/8, and what do you get when you add those?
1/8 and 6/8 would be 7/8.
And there's nothing over 8 that you had to worry about, right?
Yeah,
So
so I
then we
guess
just
I-
put the 1, right?
Yeah.
So then we got 1 and 7/8.
Yeah.
I kind of did that just.
But I like the way that you explained it because you
One
went
for
in
fun.
depth with that a little bit to show some students that may have been stuck on that a little bit exactly
Yeah.
how to do that type of problem.
Yes.
Perfectly done right there, and for your efforts and doing so great on those problems, we've got a couple of tickets to go see the Bakersfield Condors. So, have you ever been to a Condors hockey game?
Yes.
You have?
Yes.
Did you have fun?
Yes.
Well, you know what? You're going to even have more fun at this one, I think, because you're going for free now. So anyway.
They're on a roll.
Yesterday we actually had the Bakersfield Condors on our Math in the News. They are up to about 16 or 17 consecutive wins as they start getting ready for the playoffs. And I think they're playing until April, so you've got a little bit of time.
Yeah.
You can still go see the Condors and cheer for them as they get ready for the playoffs.
Yeah.
All right, you ready to do some more work?
Yes.
All right, well, we're going to give you a couple of minutes break here,
That's okay.
and we'll be back with more right after this. Today we're at Lost Hills Elementary, home of the Lobos, and we're here to
Do the math! Woo!
And here we are back at Lost Hills Elementary. We have some 5th grade students working on using straight lines to separate the letters in the field, all right? So we've got the one with the 4 X's, that was easy enough, right? And then we had the 5 Z's. Now let's go down and do the 6 W's. All right, once again, how many lines can we use?
3.
Only 3. And that, I think, is a world record as far as getting it done. You've got it done. I think you guys actually tied right there. Hey, you're pretty quick on that also. You guys are all doing pretty well. So explain to me what you've done there.
I draw 3 lines. They are all in their each box of the field, and none of them are together.
Okay, so what was the first line you drew?
The straight,
The straight. So why that one?
to see like if there's gonna be more, like to see how compare.
Okay, so you can just cut it right in half, right? So the way they're placed on the field right there, they're easy enough to see where you can cut it right in half with the first line, right? And then just using that X, you could put every other one in its own corner, right? All right, you guys up for the final one?
Yes.
This is the most difficult one. All of the V's, go for it. I think you've done that the fastest than anybody in the world, because you didn't even have to think very long about it, did you? And you only made 3 lines. You didn't have to fix anything. Which was the first line you drew? Do you remember which was the first one?
This one.
Okay, so that vertical line was the first one. Why did you place it there as opposed to someplace else?
Because
Did you have a reason why you wanted to start there?
no.
Just looked like a good spot, right? Okay, so once you did that, because did you do the same thing?
Yes.
Okay, so you kind of did it, let's see, kind of a mirror image of his, right? Because he's got the horizontal line down here, you've done it up top. But you guys ready for the final challenge?
Yes.
All right, turn the paper over. Now here's what you're going to do. Draw yourself a rectangle. Pick any letter you like, okay? And you're going to draw 6 of them in different spots, okay? So put the same letter 6 different times like we did on the other side, right? So pick any letter you want, put it in 6 different places in the rectangle, all right? So do that first. And make sure you only have 6 letters. Excellent. All right, so we're going to give you guys a minute. Go. See if any of you can solve the other person's puzzle. I didn't even get all the directions done. You were already through. Pretty quick. Hey, check you out. You guys have got the 3 lines? There's 2 lines. You only need 1 more line. Because a lot of times everybody thinks that math always has to do with numbers only, right? But in this case, did we even use numbers?
No.
Oh, what was the only number we needed to use?
Letters. 3.
3, right? We only had to use 3 lines, right? But other than that, we could put any different kind of object we wanted in there to look at it spatially and see how we could separate them into the different fields. And that, a little bit of mathematics with the kids at Lost Hills Elementary. Always a pleasure to head on out to the different schools, and thanks once again to the staff and students at Lost Hills Elementary. We have another opportunity. We're going to go back out to the construction company and visit with Scott.
Hey, we're back here live at Robert Healy Construction. A little math in the real world, and we really want to know what that looks like with math in the real world. So we're going to go back and see if we can talk a little bit about what exactly RHC does. Robert, tell us a little bit about, well, let's recap what we talked about at the very end of last time, right? You have some material that comes out of the ground, and it's a mixture of oil and gas and water. And once they separate that out into different places, you have a whole bunch of oil, and you need to move it, right? And that's when someone comes to you.
Sure.
So what do they want you to do with that, and how do you go about moving that oil?
So first they'll go to an engineering firm and say, we need to move this amount of material from point A to point B.
Okay.
And the engineering firm will do the calculations and the design, and they'll create a, in this case, a pump station or something like that. So they'll determine how big the pipes need to be, how they need to be routed, how many pumps they need to be, how big the pumps need to be. Okay. You know, pipe expands and subtract and contraction
right.
with heat and temperature. So they'll decide what the pipeline, you know, how often do you need bends and stuff in it so that it doesn't break or get twisted. So they'll do all that design, and then they'll give us a set of drawings, and our job is to take that drawing, that theoretical idea, and turn it into reality.
Okay. Okay. And so we have an example here of one of those drawings. Can you give us, again, just kind of a layman's term about what exactly is here? And this is maybe a drawing that comes from from an engineer, right?
So this is a drawing, and this is a kind of a site overview drawing of a project we did, and this is a pump station. So this is taking from one end of the oil field and it's moving the oil to a different facility at the other end of the oil field here. So you can see there's kind of a receiving vessel there to stack the oil. These are all a number of pumps. So these pumps all take the oil in from one side and push it out the other. And then this is electrical to control all these pumps, and it's all automated so they know, you know, when to turn the pumps on, when to turn the pumps off, and which ones to bypass so they can service and all that kind of stuff.
Right. And so we're talking about lots of material, lots of power to this station here, and lots of equipment, right? And so there's got to be some math in there. Sure. So then it comes to you, and you have to be able to put this together. Over here, a little bit of here. So tell us, when you start to think about some math about this project, where are you starting? Maybe we'll start at the top here, right?
So, well, we kind of just, for this example, I took a very simple foundation.
Okay.
So if you look at this drawing, there's a number of foundations. Each one of those pumps has a foundation. Each one of those buildings has a foundation.
So like a concrete foundation to support that piece of equipment. Right. Okay, that makes sense.
Fairly typical that we do like that. So we have to calculate, kind of comes in the organization, kind of everybody in the organization does that calculation. So our estimators will take that and calculate how much concrete they need to do, so they can figure out what the concrete cost is going to be, and then what our labor cost to build that is.
Right.
Then the superintendent in the field, he's got to figure out how much concrete he needs to order, so he'll do those calculations.
Yeah.
And then even the carpenters, they got to know how much form material to order, so they would need to know the perimeter or different things like that. So everybody kind of will recalculate that same calculation 3 or 4 times throughout the process, and it's also a check. So if the estimator calculates one thing and the foreman calculates something different and they don't get the same answer, then they can kind of get together and figure out who made the mistake.
Right, right. And I like what you said too. I mean, the people that are working out there, regardless of what the plan says, have to have an idea about what's going on and making sure that the numbers make sense, right? So take us through a couple of these numbers here real quick. We're calculating some area. Is this the area, the square footage that the cement's going to cover? Is that right?
Sure. So what we're going to do is calculate the volume, ultimately calculate the volume. And the way I typically do that is we'll calculate the area and then multiply it by the thickness or the height of the slab.
That makes sense. Okay.
So one of the first things we have to do is, if you notice in this drawing, it's in 15 foot 6 inches. So we need to convert that from feet to inches to feet and a decimal point so we can do the math easier, right? So the first thing we do is we take this 6 inches, and we know that there's 12 inches in a foot. So we take 6, divide it by 12 to get 0.5. So this is 15.5 feet, or 15 feet 6 inches. So that's how we get the width.
That's where this number comes from here, yeah. Okay, good.
15.5. Then, if you can see, we got to figure out the length. Well, on this one, it's 22 feet 8 inches. Plus, we got 1 foot 4 inches here they have called out. So we have to add those two numbers together. So we can add the 22 and the 1 to get 23 feet. And then we got to add the 8 inches and the 4 inches. And we know 8 plus 4 is 12, which is another foot. So we add that to the 23 feet to get 24 foot length.
Okay, so that's where these numbers are coming from. Even though you might not see those specific numbers on there, you're making them so that we can do this problem here. Talk about square footage, okay.
So really simple to calculate the area, you get the square footage. How do we do that? Length times width, right?
Yep.
So I did the math already a little bit, so that gives us 372 square feet.
Good, okay.
So, in this particular example, if you'll notice at the bottom of the drawing here, it's not a perfect rectangle, we have a cutout here. So we have to figure out how much do we need to subtract for this cutout.
Yeah.
And it's not a simple square or something like that. If you look at it.
It never is. It's always something different.
We can show it over here.
Okay.
I kind of drew it up over here.
Yeah.
When we look at it, we really have two equilateral triangles and a rectangle in the middle.
Okay.
So we're going to calculate the area of each triangle first. And we know I already converted the 1 foot 4 inches to feet, which is 1.3.
Okay.
And we know it's equilateral triangle, so 1 point is equal on both sides.
Yeah.
So to get the area of that triangle, it's 1.3 times 1.3 for 1.69.
Good.
And it's a triangle, so we have to divide that by 2,
that
right?
Area is half that.
So we divide it by 2. So the area of a triangle is 0.845. That's square. But we got two triangles, so again, we're going to take the 8.45, multiply it times 2 for a total area of 1.69.
Okay. Wow. There's so much stuff to do. We need to make sure that we get this all straight in our heads. I really like how you have the pictures that go along with the numbers, and we'll see how this all goes back to it, because looks like we're gonna subtract that part out. Man, this is looking pretty good. I know there's some more math problems to do back in the studio though, but when we come back, we'll make sure that we get this final project and the cement poured. Well, everything but the cement poured. Back to you in the studio, Mike.
All right, thanks for that. Hey, we do have phone tutors available until 5:30. We've got more phone calls to get to, but first we're going to work with Madeline a little bit on another one of her word problems. So, over to the board, young lady. Let's get ready. First of all, do you eat oatmeal?
Yes.
You like oatmeal?
Yeah.
Do you have a favorite flavor?
Brown sugar.
Brown sugar? All right. Sounds like it would be tasty.
Cinnamon.
Allie's little sister wanted to help her make some oatmeal cookies. First, she put 5/8 cup of oatmeal in the bowl.
Okay.
Next, she added another 5/8 cup of oatmeal. Finally, she added another 5/8 cup of oatmeal. We need to know how much oatmeal was there altogether.
Plus.
So she's adding it. It even says that in the problem, huh?
Okay, so we can rewrite these two 5/8 into 10/8. Then we have 10/8 plus 5/8. And then 10 plus 5 equals 15/8. Oh.
Whoops.
Okay. And then remember that we did this before.
Yeah.
We simplified.
Oh, it's the same numbers too, I think.
Yeah.
Huh?
We rewrote this, and it was 1 7/8. But in case you were wondering how I got that, It was 1 is equal to 8/8 plus 7/8 up here is equal to 15/8, which is up here.
Right. Okay, so I have a question for you because I happen to know that on your homework it says you should draw, right?
Yes.
So let's go ahead and go over how you would draw this. You want me to scoot it back up or down? Or
Down.
that way?
Okay, yeah.
Or you want more room?
No, this is good.
You want to draw it from, can you fit it there? Or I can go up.
So this would probably be divided into thirds. So we would draw a tape diagram. Then that would be 2/3.
Is that because there's 3 numbers? Is that
Be 3.
Is that why you got thirds?
Yeah.
Okay.
Then 5/8, 5/8, and 5/8. Using all of this, and then we could combine these two and erase this line, and then it's no longer a tape diagram, it's more of a rectangle now. Then just get rid of, pretend these aren't there, and this is 10/8. That can be simplified.
I think in this case though, since you want to keep your denominator the same as your other denominator,
so
you're probably
we
better
don't
to leave it like that.
Don't need to do that. So 10/8 plus 5/8, again, is 15/8, which is rewritten into 1 and 7/8
cups of oatmeal.
cups.
There you go. Nicely done. You have got these numbers under control. We do have phone tutors available until 5:30. Right now we're going to go to the phones, and a young lady from Hart Elementary. Ruby, how are you today?
I'm good. How are you?
Excellent myself. As soon as you're ready, let's hear what you're working on.
Okay. So, for starters, you would do the matcher's price, which is equal to $400.
Okay, wait, can you tell me the context of your problem?
So read the
It's kind of
problem.
like sales and tax.
Okay, so you're finding sales tax on a purchase?
Yes.
Okay, so you got $400, all right. Go ahead.
And then I have a blanket that's $199.99.
Okay.
And then I have bed sheets that are $149.99.
$149.99?
Yes.
All right.
Then there's pillows, which is $29.99.
$29.99?
Yep.
Okay.
And then I have to find the subtotal,
Okay.
as well as the tax, which should be 6.5% of the total.
So your tax is
And then-
6.5%, all right.
Then last but not least, the total purchase price is what I have to find out.
Okay, so you need the subtotal, the tax amount, and the final total.
Yes.
Okay. So have you already found your subtotal by adding?
Yes.
Okay, so what did you get?
I got $779.97.
$797?
$779.
$779? Okay, sorry. I wrote it backwards. Okay, $779.97. All right.
All right. Now, whoa, hold on there. Before we keep going, let's verify.
Let's verify.
I added all the numbers up, and I got the $779.97.
All right.
So you
we
got
can
that
keep
also.
going.
So we got to verify it with the calculator. All right. And so how do you find your 6.5% tax? So there's your subtotal. That's one of your parts you had to find, right? So
Yep.
6.5%. How are you guys in your class doing it?
You would do $779.97 times 0.065.
Okay. So you turned your percentage into a decimal. You multiply it out.
Yeah.
Okay. Have you done that part?
Yeah.
Or I have Madeline here.
Well, let's
She's
have
gonna tell me.
Madeline read off the whole decimal.
Okay,
So
read me
Madeline,
the
read
whole
the
thing,
whole
Madeline.
decimal.
50.69805.
Okay, is
Now,
that what
is
you
that-
got, Ruby? 50.69805 before you do anything to it?
Yes.
Okay. So then, since this is money and it's a tax amount, right, we need to make sure that it makes sense in a money context, right? So money can
Yeah.
only go to the penny, which would be the hundredths place, so we need to round it. So we're either going to leave it as $50.69 or it's going to increase a penny if it's big enough. So what do you think it's big enough?
Yes.
Okay, because that's an 8 right there. So then $50.70, right, would be the tax amount.
Yes.
Okay, so we got our subtotal, and then we got our tax amount. So what should we do to get our final total?
You would add the tax amount to the subtotal.
Yeah, because tax makes your price increase, right? So when you add it, 50.70, let's see, I can do this without a calculator, right? Okay, 78, did you get 830.67, $830.67?
Yes.
Okay.
There you go.
There you
Nicely
go.
done. $830 for, what was it, a mattress, the blanket, the pillows, and everything?
Yeah.
All right.
So,
Well, congratulations, Ruby. You're going to go to a game of your choice at CSUB, courtesy of the CSUB Athletics Department. So I know there's a few basketball games left. They have swimming and diving. They've got baseball started up. So it's all up to you. All right, Hotshot, you ready?
Yeah.
I know you were working on that other one, but let's erase that board, and we're going to give you a different type of problem. We are through with
Okay.
the fractions for the day.
Okay.
all right,
I'm
this is
quite
your
confident
challenge.
you've got those under the belt. All right, so this is a favorite problem. Cindy put 4 4s up on the board.
Oh, I love these. Oh, let me scoot them down. Oh, sorry. Okay, so 4, 4, 4, 4.
All right, Madeline at the end put an equal sign. And Madeline, choose a number between 1 and 10.
9.
9, all right,
Okay,
put a
so-
9 at the end. Now, here are the rules of the game. You have to use all 4 4s. You may put any symbols you like in between them. Add, subtract, multiply, divide, square roots, factorials, decimals,
Okay.
anything at all that you like.
Okay.
And all 4 4s have to equal 9.
Okay.
So as you're thinking about it, explain out loud what your process is.
So you got to try and figure out what to do with those to make it equal 9. So you can start just saying what you think and then redo it if you know. What do you think? What should you try?
First, I was thinking plus
Okay.
4 fourths plus 4 fourths equals 8.
All right.
Then I realized that there was no 1.
Okay,
go
so
with
what can we
it.
do to get a 1?
We could.
Do you guys do order of operations already in 4th grade?
Yeah.
Okay, so we're
Okay.
thinking order of operations here, right? So we got these 2 4s taken care of. We need to do something with those 2 4s. Okay. All right.
So that would be. So 4 and 4 equal 8. Then 4 divided by 4 equals 1. And then bring the plus sign down here. Plus equals 9.
Nice job.
That was awesome. All right, Hotshot, bring the board down a little bit. Whoa, all right, we know what you did the first time.
Okay.
Now I want you to do the 4 4s, get them equal to 9, but do it a different way.
Okay.
Because there's always more than one way to do it. So the first thing you did was you added and then added the,
That's what you did the first time. She's just rewriting
right, so
it
you
for
did the 8 plus
that's
1.
your
So
first
that's one
Let's
way
move
to do
A
it.
little bit. Just
So now I
okay.
want you to find a different way to do it.
With the same 9.
Right, you
Yeah,
still have to
still
get 9.
equaling 9, but something different with the 4s or with the math.
Okay. I could.
Let's clarify, Mr. Kushine. When you say something different, can she still use the same operations, just not necessarily in the same spots?
Okay, we're
Or
not.
do you want her to be totally different?
I'm going to leave this up to Madeline.
Okay.
Well, the simpler way to do it would just be to redo my other way, which would, but just in the
Right, so now you've got
spots.
1 plus 4 is 5 plus 4 is 9,
yeah.
all right? All right, technically that is a different way,
Yes.
so let's find a third way now.
Okay. 4 equals 9. So what I've got in my head right now is we could do the square root of 4, which would be 16.
So that's
Well,
the square of 4,
2.
which
Yeah.
you can't do that though,
Yes.
right?
Right, you can't add an
You can
exponent.
do, okay, so square root is this,
Oh,
which is what number times the same number equals 4.
oh.
So you could
That
turn a
would be-
4 into a 2
So
if
that
you
can become a
needed
2, because 2
Yeah.
times 2 is 4. So you could do that, but you can't like do an exponent, which is what you were thinking.
Yeah.
Okay.
it. And if you wanted 16, you would simply go 4 times 4.
Yeah.
True.
So 4 times 4, 16. And then I was thinking we could do plus the 4, which would be 24.
So what's 16 plus 4?
16.
Or are you adding both
Six.
4s? Or just one?
I'm doing 16.
Mm-hmm.
Oh, wait, that's not.
There we go.
Yeah, it's 20. So 20. So plus 4 equals 20.
So now you're at 20, and you want to try to get to a 9. So I don't think
I don't think that'll
we can do
work.
anything with 4 and 20 to get 9,
So
right?
here, I'm going to help you out a little bit.
All right.
All right, so get rid of the bottom line that you've got.
This part?
Right, you know what, make a circle around it with the eraser.
And then tap it.
Almost got it. All right, just move the board down a little bit, and then we'll try this. There you go. Try, okay, so make your 4 4s.
Okay, that's, okay, so I can just erase those and then,
Okay, so we got our 4 4s. Still trying to make it equal 9 in a different way than we did before.
Okay,
All right.
between the second and third one, put a division symbol. Okay, and then go minus, after the third one, put a minus, and then the square root of 4. So the last one's going to have a square root symbol on it.
So it looks like
square root again?
this.
All right, so I'm going to have
Kinda
you
like a
girls
check
work
mark
on
with a line.
that while we head out to our
All right.
last visit out at RHC with
So we got to
Scott.
figure out what goes here,
That
basically,
would
right?
be 1.
Hey, we're back, and we really want to know. I know everyone's waiting on pins and needles. We want to know a little bit more about how we pour this pad of concrete. So, Robert, we got to get back to this real quick. I'm really curious about how it's all going on. Tell us a little bit about where we left off here with this cutout from the pad, right?
Yeah, we're calculating the amount of area we have to subtract from our pad there, and we calculated the volume or the area of the triangle, and then we got to calculate the area of the rectangle. I've kind of shortened this up for you, but it's, take my word for it, it's 2.33 width by 1.33 long.
Okay.
So to give us an area of the rectangle of 3.0989.
Yeah, okay. So this was the original area of this whole entire thing, but now we have to take out this little piece.
Yeah, we gotta take out that little piece. So
Okay.
we take our 3.0989 to subtract out the rectangle. That gives us 368.9011 square feet. Wow. And then we have to subtract out our triangles that we figured out from here, which gives us 368.056. So that's the area of our pad,
Okay.
less our cutout.
Right.
But-
So this is the actual area of this pad here. That totally makes sense. Okay, good.
But what we're trying to figure out is the volume of the pad.
Right, because now we're talking 3 dimensions.
Yes.
Yeah, because you don't want just a layer of cement that's, you know, super thin. We want to make sure it's going to hold what it needs to hold. Okay.
So over here, I happen to have a note. It's on a different drawing, and I brought it over, that the pad is 2 feet thick.
Okay.
So we're going to take our area of the pad, which is the width and length, and to get the volume, we have to go width, length, and height, correct?
Right.
So our height is 2.
Yep.
So we multiply our area times our height to get our volume of 736.11 square feet, or cubic feet.
Right.
Feet,
Yeah,
right?
there you go. And
So
you can't order concrete in cubic feet, right?
Well, that's the problem. Concrete companies want it in cubic yards.
Right.
So-
Which is 3 feet wide, 3 feet long, and 3 feet high. If you think about a little square of concrete, that's what we're looking at there, right?
Exactly.
Okay.
So 3 times 3 times 3 is 27.
That's where you got the 27. All right.
So we're going to divide this 736 cubic feet by 27 cubic feet to convert to cubic yards.
Right.
So to do the math for us, that's 27.2634, which is the volume of the pad in cubic yards.
Wow. So this is how much cement you need when you go and talk to a cement company. Hey, this is how much we need delivered to the site.
Sure.
Yeah.
And then, you know, we might actually take and say, well, that's the exact amount, but we don't live in a perfect world. We spill some, we lose some.
Yeah.
So sometimes I might take and add 10% to this.
Okay.
So I would just take the easy part is I just take my decimal, move it over 1.
Yep.
And say, well, I want to add 2.7 more yards.
Okay.
And round it up. So I'd probably order 30 yards of concrete.
Completely makes sense. Yeah, and you're doing a little math in your head there too. And then so if you have 30 yards of concrete, now we'll do a little bit of more math, and we don't need to be too technical, but how many yards does one truck hold?
Typically 9, sometimes
Okay.
10.
Okay.
But, you know, in this
You can
case,
get one of those 10s would be nice because you have about 30 and about 3 trucks,
I
right?
concrete guy say, I need 30 yards. Can you squeeze it into 3 trucks for me? You know?
I gotcha. Right. And of course, the people that are out there have to know about these numbers too, right? So they're not ordering 30 trucks; they're ordering 30 cubic yards, and they need to know about what's coming in.
How many trucks that really means? Because
Yeah.
you gotta, you know, you don't want if 30 trucks show up, you know, you got a problem.
That's right. Yeah.
If
We're
one truck
ahead of
shows
time.
up, you're kind of like, hey, we have a problem.
We're a little short. We can't start pouring unless we know we have more material. Wow, so a lot of math going on. We talked a little earlier off camera, but just remind me about that conversation about when you go and work in the oil fields now, it really is not as much, you have to be smart, right? You have to know some math no matter what role you have in the oil fields.
Sure, yeah, it's become a much more, the requirements have become much more complicated now. I guess one way, you know, computers. Everybody uses computers now. We use computers to do time. We use computers to do everything. Even the simplest jobs now, forklift operators, they have to be able to calculate loads. They have to be able to read load charts. So almost everybody's got to be able to do math in some way, shape, or form in another. So
hey, you hear that? Almost everybody has to be able to do math. I love it. That's the important message we're getting across here. We're so grateful for your time. On your next project, do us a favor here. We have the famous Do the Math tile. Maybe you can put that up there on one of those pumps. Thanks for your time today. Really appreciate it. Learned a whole bunch of stuff. I know that I learned a lot of stuff. Hey, we'll make sure that we get a little more math in the real world next week. But for today, we're done. Back to the studio.
All right, thanks for that, Scott, and also thanks to Robert and all the folks out at RHC Construction. Some excellent math and how it's applied in the real world. Did you have fun today?
Yeah.
I think you're going to be an excellent ambassador for Do the Math. You know what that means?
Yeah.
What? It means you have to tell people all about Do the Math. Can you do that?
Yeah.
This is your official uniform, and you need to wear that every day that you go to school. Can you do that?
No.
What? You just said you'd be an excellent ambassador. Well, wear it sometimes at school. You can do that?
Yeah.
All right. All right. Once again, we do have phone tutors available until 5:30. Madeline, our newest ambassador. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.